Okay, now go.
Okay, welcome to the let's get my date right here. Um, April 21st, 2026 session of TAPR and HamSCI technical session. My name is Dave, KV0S, and this week I've been cleaning the shack, um, working on the antennas a little bit, and the weather starting to do the yard work, which uh, starts up this time of year. So that's about it. Uh, Next on the list is Nathaniel, W2NAF. Go ahead.
Thanks, Steve. I'm just continuing to try to keep everything going. Write exams for class, write reports for different projects, make sure that I'm somewhat on top of my emails, which is always challenging, and keeping everything going. Back to net.
Very good. Next on the list is Dave, KD0EAG. Go ahead, Dave.
Hello. Yeah, I'm doing lots of things, not too many of them directly related to this project, trying to clean up my local um, network environment and some other resources, mostly taking my time, and also have lots of interruptions these days. But that's really all I have to say. Over to y'all. Good to see you.
Are you there, Dave?
Yes, I got dumped off.
There's
And
act I see two of you. One of you is frozen.
yeah, and
Did,
so I am back. Um,
did you hear
and
me? Weird
yes,
thing.
I did hear you.
Okay.
So, um, let me get my list of participants again. And next on the list, I have Paul, WB6, CXC. Are you dealing with weather there, or I'm not hearing Paul. Your mic muted.
Okay, can you hear me now?
Yes.
Thank you. I'm up in Friday Harbor. The weather's beautiful. A little bit cloudy and hazy at times, but blue sky and sun at the moment, so no problems at all.
And you're just life is wonderful, huh?
Life is always wonderful, but yeah, it's good. No complaints.
Okay.
Let's see.
Any other comments?
Um, Dave, I'm not sure if you're on my list, the design review for the TAPR-X 88, but
Yeah.
I did release what I hope is maybe could possibly be, with luck, the final design before we figure out how to get the thing built. Um, I am looking. Okay, I'm sorry. I'm reviewing a comment right now.
Yeah.
Looks like, yeah, just typo stuff. Okay, good. Um,
Good.
I've had a few comments, but so far, but only a few. So far,
Yeah.
nobody's pointed out any egregious errors. I am working on my um, the Hamvention uh,
Talk.
presentation. I think I'm making good progress there. Um, I've submitted like a 500 word piece to ARRL because it sounds like they're going to do a pretty good section on the HamSCI conference. Nathaniel, do you know? You said special edition or special feature. Do you know any of the details?
not specifically, but it sounds like they are going to do something similar to last year because I know they've been going around. So last year, what they did was in the August issue, they dedicated like 12 pages to HamSci, and
Wow.
they had like two larger scale articles, and actually, and then they had each of the people or many of the people who gave presentations at the HamSci workshop write up a 500-word thing on their particular project. And so this is where I sent out an email earlier today saying that I'm tapped to write some sort of an article about how to set up one of these personal space weather stations. And so I have to get that done in a week or so, among many other things. So,
Yeah, sounds like less than, I mean, when I was asked to do this, it was like a week and a half, and that was a week ago. So
yeah.
check your schedule.
So, oh, I know. So it's going. I'm supposed to have it by May 1st. So it's it is busy. But one of the things that came out of last year, and this was a total surprise to me. Um, I wrote an article for last year's special section on HamSci about large scale traveling and ionospheric disturbances. I did it with Ethan Miller, and they actually sent me this in the mail today, and it's the 2025 Bill Orr Technical Writing Award. So
Wow.
I was totally surprised to get that in my mailbox today, but this is like pretty impressive.
Oh, that's really great. Yeah,
Yeah.
so Dave, yeah, that's been my job. I've been looking a few other things I've been working on, but they're not definitely not ready for prime time yet. So, but I'll be excited to share those soon. I think there might be useful things.
I
So back to net, I guess.
Yeah, I can say that we are going to really make a push to get these personal space weather stations out the door this year. I am really I'm meeting with Kyoman tomorrow morning to talk about some of the funding. And I really I think the right thing to do is to figure out how to get those time injectors in with this system.
I will just go ahead and
I'll think
I'll have some made. I mean, I'm going to assume one way or another, enough
I will
people will be able to pay for them that I won't be horribly out of pocket on it.
Yeah, I'm gonna figure out how to do it.
Okay.
Because I think it's really important. I think this is a really critical piece of the puzzle. And if we don't do it now, it's gonna just get harder later. And I think we just do it, get them out, and then we'll have nice results.
Yeah, obviously I'm really gung ho on this thing, but
Yeah,
I'm happy to support it however I can.
I think it's important, so I
Okay.
think we should do it.
Did you get my the uh, the timestamp that I sent you, time sync that I sent you yet?
I don't know. I haven't been up in the mailroom, and I think you sent it attention to Emma
That's all
Moran,
right.
and
I can
yeah,
track it.
and
It's
okay, and it goes to our mailroom, and then it has to get brought to somewhere else on campus, and so
okay.
there's a and today is Monday after a weekend, so
Okay. Yeah.
yeah.
Dave, back to net. And you're muted, I think, Dave.
I'm back again, and hopefully I won't get dropped off again. But next on the list, we have Clint, uh, K7 OEI. Go ahead.
Hello. Yeah, couple of projects. As probably if you caught the start of it, did the ERRL-FMT. That's sort of a way of nerding out. This time, I remembered that it actually occurred and did it. And Phil talked more about it. Did better than I, but got pretty good results. Despite Doppler shifting. And after several years of languishing, I'm just finishing the touches on a little QMX RAV1 that I just barely got out of the box a couple days ago. And I'm building it in a manner that wasn't really designed to be built, but it's working fine. And also got the parts for So probably in middle May sometime, we'll be switching the Utah 888s to a 30 meg reference on the 888s from a GPS DO and eliminating the BODNAR entirely. We have a GPS DO on site because the BODNARs are good, but they're not great. So we're going to try to go with something great since it's something we already have on site and powered up. But anyway.
You gonna do the triple the 10 megahertz thing or what?
Yeah, I actually got from there's that 8-pin chip that was discontinued. Well, there's a 14-pin that does more things. It's the same chip more or less, but with more divisors. I'm just going to build. I ordered some boards with I designed some boards to take that chip and some of those chips. So I'll just do that. So it'll be tripled, yeah, but with a PLL. So it'll be good enough, I hope. Anyway, back to you.
Very good. Next on the list is David H. W6OQ. Go ahead.
So I'm here stuffing my face, so I got the camera off. But yeah, this week I looked over Paul's documents and, just before the meeting here, sent him a couple notes on it. That's about it. Thanks.
Okay. Next on the list is David McGaw, N1HAC. Go ahead.
Good evening, everyone. Just to preface everything, we got an inch of snow yesterday, and it's supposed to get down to 20 tonight. So winter is not over quite.
Wow.
And yeah, I'll make a point of looking at the schematic. And let's see what else is going on. Oh, playing with our ground station stuff and making progress in actually getting the rotators to work and things like that. Though I'd hurt my back last week just sitting on the couch. Sometimes things happen. You sit down on the couch, you do things, you get up and you can't get up. But it's getting better. Known problem. But meant that I haven't been able to put some things up on the roof yet, but hopefully this week. And I guess that's about it. Oh, I did also, of course, I got a request from ARL for a blurb on the cinema movie project. So that's, welcome. And we'll be working on that to get that into the special edition as well. So back to Nat.
Okay. Next on the list is Jay Schwartz, WB8 SBI. Go ahead, Jay.
Yeah, good evening, everybody. The only thing ham radio wise that's new with me is that I reconfirmed my hotel reservations for the pilgrimage next month. And hopefully we'll see everybody there. Everybody here, and 36,000 others of our best friends from all over the world. So 7-3 to everybody. Take care. Stay safe. Back to net.
Okay. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. It's been a definitely a busy week for me. Some non-VLF related items, but also some other VLF related items. One of the most exciting things so far is that the Whistler Catcher logo is finished, so I can unveil that this meeting, and I'm sure that everybody would want to see it. It looks absolutely beautiful. Big thank you to Creative Services at the University of Scranton for creating such a beautiful logo. So the wheels in my mind got turning on about things like asset tracking and for the systems that go out. The plan is, at least with some further discussion, is on each of the items, each of the system components, there's going to be a sticker, just as a basic asset tracking thing, but also a good opportunity to put the logo on that sticker as well. And because it looks so cool, it just makes it all that much better. So I'm very excited about this logo, and I can't wait to show it. That's all I have. Back to the net.
Okay. Next on the list, let's see, we've had Paul, so it's Phil, K9Q. Go ahead.
Hey guys, yeah, as I mentioned at the beginning of this thing, I entered the ARL frequency measurement test a couple days ago for the first time, and I guess I had beginner's luck. I seem to have done pretty well. I just recorded the data, not knowing what I was going to do with it. The next night, I sat down and started running programs from scratch to analyze it, and seemed to have done all right. But it certainly revealed how much I don't know about the ionosphere. So I figured probably here's somebody who can help me with that.
Well, there's a few people.
Yeah, a
So
few people. Yeah. There seems to be raging debates among the FMT nuts about the value utility of correcting for Doppler from WWV and CHU. Out from where I see out here, it was definitely worth doing. I mean, there was strongly correlated. My only problem is that I actually made three entries myself, my stationary in San Diego, KFS and KPH. All three came in the green box, but I overcorrected KFS and KPH because they had erroneously large corrections because of a bug in my software that I've since corrected that simply didn't bite me here. It happened because of the way I handled frequencies close to the DC bin in an FFT doing quadratic interpolation. It wasn't really a bug, it was just a limitation. And it wasn't giving results as accurate as it could have. But anyway, a little, some of this statistical stuff actually seems to have a use. It always made my eyes glaze over in school, but when you can actually use it for something and maybe even win a contest, then suddenly I become interested in learning about it.
yes, I'm glad somebody said that. It's been a career teaching it to undergraduate students, and
Well, there you go. You got to create contests, of some
yeah,
kind.
there we go. Okay, is that it, Phil?
Yeah, for now.
Okay. Next on the list, let's see, I got to make sure I didn't skip anything. We have Scott, and I want to tell Scott I am making progress. By the weekend, I should know if your proposal is going to be good. I'm pretty confident, though.
Okay, glad to hear it. One suggestion that came up at work, it might be a good idea to screenshot the current Zoom configuration.
Oh, yes.
I'm sure you've already thought of that. Great.
Yeah.
As far as my week went, I took a beating from Python, Farlap, and PyLap this week. That was pretty nasty. I did watch an interesting documentary, I guess last week, about the Voyager project, kind of COVID era thing. It's called It's Quieter in the Twilight. Might be worth watching. And I was curious, are there any plans for HamSCI for this upcoming August eclipse in Spain? And that's it for me.
David Kasdan is coordinating some of that.
So if you have an interest, Scott, Kasdan's one to contact.
Got it. Thanks.
Okay. Next on the list is Tom N5EG. Go ahead, Tom.
Okay, good evening, Dave, everyone in the group. It's been a real busy week on the project. I finally cracked Synology design constraints, or the Xilinx variant of it, and got output timing to work on the FPGA. It's one of those things where you can look at the simulation and it all looks beautiful, and the tools tell you everything's wrong. And so I trusted my eyes more. I found I had to add a constraint for something happening one clock cycle after the input. And once it did that, all the timing fell into place. And to finish the schematic on the quad board, it's 17 pages. And I've started layout on the revised board. I was able to salvage about half of the circuitry from the old design. And I've started out with an 8-layer design this time. The previous one was a 4-layer board. So I think it'll fit in 8, but it'll still be a little tricky. So working on a few fronts, back to the group.
Very good. And I see Michael Howland jumped in here. So we have AC0G/ND. Go ahead.
Yeah, that's right. I'm up here in North Dakota. I had a family emergency that required me to kind of drop everything and head up here. So, although nothing disastrous going on, some details to attend to, but not too bad overall. Uh, Rob and I have been working on um, putting together a way to organize a whole suite of HamSCI applications. So that's uh, been rather large on the to-do list. I did want to acknowledge Paul's query and Scott's about um, coordinating how we're approaching the whole timing thing. So maybe we can set up something to discuss what our various specific efforts are and how we can support each other and what the shape of those things looks like. Rob and I have made some terrific progress, I think, on putting together a kind of overarching framework to just dangle um, some clients. The clients can, for the most part, we're trying to design this in such a way that the clients can run independently and be standalone. But if we want to run them together under the aegis of what we're, for lack of a better word, and to stimulate our own funny bones calling Sigmund, is turning out to be looking pretty good at this point. And hopefully we'll uh, have it all set up in a state that we can start asking people to test in the relatively near future, hopefully before HamSCI, or at least at HamSCI, we can show what's going on. Maybe we can even show what's going on sooner rather than later, but there's still some rough edges that we gotta have to sort out. We're testing various architectures as well, both everything on one machine versus one machine that's divided into Proxmox virtual machines versus separate machines running on a LAN, and trying to make sure it all kind of hangs together seamlessly. It's looking like there's a workable solution for it, and that it'll help both understandability for everybody and ease of maintenance, and hopefully broaden the number of people who can figure out what the hell is going on, and help debug their own machines, and even contribute and add and improve and augment what we're doing. So that is our fervent hope. In fact,
Okay. Well, that leaves us to Rob Robinette. So you can tell the other side of the story.
Well, yes, I mean, the process, we, one of the reasons we renamed the program is that it's Whisper Daemon is only one of the suite of applications which can run in this environment. And so it's really inappropriate to call this a Whisper Daemon project. This is a general signal processing framework and infrastructure, where in most cases K9Q and the RX 888 are the core. And then there's a variety of optional programs that can be added on. So Whisper Daemon is one of them. K9Q Web is another. The JFT decoders, the HF, Phil's HFDL monitoring program. All these are clients of K9Q radio. So that's the motivation for the name change, and we asked for our friend Claude for some suggestions for renaming, and Michael and I together thought that Sigmund was the best, best described what we have now. So and what we're doing. So I have pretty much finished the Whisper Daemon version 4 that will be kind of a plug-in into this environment. It does work standalone. It doesn't require Sigmund, as I think uh, other of the plugins may not have that built into them, but Whisper Daemon, because of its uh, inheritance, does know how to install K9Q and the other components that it needs. But in most cases, I expect that it'll be running in the Sigmund environment. Um, so it's running it's I think at this point the Whisper Daemon functionality in version 4 is complete. I don't know that it seems we're posting spots as AI6 no AC0G/B1 is reporter, and um, it's seems to, Michael's a reasonably it's on a compromised antenna, and yet it's doing quite well. We've uncovered some problems with WhisperNet, which we always knew we have, I think, better insight into them, strange ones, than that they kind of reject certain spot reports, individual spot reports, uh, for reasons that I can't discern, and the WhisperNet people won't respond to my query, or haven't yet responded to my query of why are you dropping these spots. Um, but other than that, it's also reporting the extended spot information that we use to get the noise level data is being recorded into our servers. All the functionality is there in the Whisper Daemon world. So it's Michael and I are turning our attention to the Sigmund and integrating and making a very user-friendly environment. Very, almost no typing on the command line will be required. So that's what I've been up to. Back to net. So.
That
Okay.
sounds extremely exciting.
Yes.
That's something that I have wanted for a long time, and that's amazing.
I've been talking to Michael and about it, and I've gotten quite excited after hearing what
Yeah,
what he and Rob are up to.
This sounds absolutely fantastic.
Well, it's we I'm trying to bring up a brief demo, but I can't, for some reason I can't find it right now. So it's a just give you a taste. Michael may have a window open he could share. I don't know.
I'll check, but
Yeah.
one example is PSK, FT4 and FT8 currently now run as a standalone client underneath the Sigmund Aegis. You can turn it on, you can turn it off. Uploads are happening without having to in the same client model that all the other ones share, which is helpful. And part of the objective is then as we develop new clients, so if we're developing CASAS array signals, if we're developing a CODAR client, if we're developing a SuperDARN client, it'll all plug in under this framework to enable monitoring stuff.
This is exactly what I had imagined from the beginning. So congratulations on doing it.
Well, I will say with all, it would have been impossible 6 months ago, but for the development and our learning curve with respect to employing AI to assist along the way. It's been just a tremendous potentiator for our efforts. This kind of stuff would have taken forever if it had been just our own coding skills. So
I completely agree with that. And I mean, Rob you're the one who told me back at AGU this December that I should start using Claude, and I have. And I, for me too, it has just been an amazing, um, an amazing tool to increase my productivity, and it's gotten me out of a bind on a number of things.
I've been used after in the last month on this project. I've been using Claude Code, um,
Mhm.
which um, which is a program you run on the target machine.
I
And
that's yeah, that's what I do.
okay, I
Yeah.
hadn't done that initially. I was doing, I was querying Claude and then doing copy and paste and SCPs back and forth until I realized that there was this Claude Code that would do it much better. So it's
Oh yeah, I run it. I run it as a plugin in VS Code, so it's completely integrated with my IDE. And
yeah.
yeah, I just told it, have it connect to a server. I'm like, please set up Let's Encrypt. It just reconfigures my servers for me. It's just amazing.
It,
It solved. We had a bot attack on hamsci.org the other day.
yeah.
It solved the problem in like 15 minutes. Put in the correct firewall rules, fixed it all.
Yeah, it's amazing. I had, um, yeah, I've found that you can just so rapidly fix things. And I don't even ask the question. I just like I've just done a copy and paste thing, fix this,
Yeah.
and it just goes and does it and plugs it in. What was amazing was I went to implement now the client server communication. And I spent months working on that to get that figure out the aligning fields and messages and files. I just showed Claude how it could access over SSH command could access the server. It went and figured out all of the problems, communications problems, and just figured the whole thing out in like 15 minutes. It was just I didn't have to do anything. I just sat there and watched it. It was absolutely
And
amazing.
I'll tell you, the most amazing thing about Claude is that Rob directs Claude via voice. And you know how hard it is to understand Rob just in normal human English. Claude manages to figure it out, and actually execute exactly what Rob has in mind. Claude knows Rob's mind better than Rob and better than it's possible for humans to understand. So it's pretty awesome.
You know,
This is this is something else Claude helped me out with this week. Over the past couple of years, we've been putting the ham radio data up on the MIT Madrigal database, and I've never had the time to actually look at that data and like work with it. And I finally, had some motivation and the ability to use Claude over the past week to work on that problem. And it's been really good because it's identified some problems with that over 5 terabyte data set. And so now I can start working on them. And then it also helped me. This is the reverse speaking network data broken out by band from 2009 up through the present day. And you can see the solar F10.7 flux is plotted on top. And we have, I don't even know, hundreds, thousands, millions, 1.7 billion CW and RIDI spots that you're looking at here. And you can just see the solar cycle pop out beautifully here. You can see the byte out, when you have on the low part of the solar cycle, 10 and 15 meters go away. But 80 and 160, they come up. I mean, you could just see this, and you can see the coverage of the ham radio spots from around the world. And yeah, again, Claude helped me to just update my code, make sure it was optimized to handle these large data sets, and get this done in a reasonable amount of time with screaming toddlers running everywhere. So, and then the other cool thing that it did was I had a situation. I'm trying to teach at the Blind Association, and they and one person is having a difficult time accessing um, material on about the technician license on her iPhone, and the MP3s for the uh, course for the technician material was out of date, and the websites that people were using, um, that had the information on it, they were difficult to navigate with screen readers. So I was able to just give Claude the Claude Code. I Claude Code used the gave it access to the Handy Ham text files with all of the lectures, and it used the Microsoft text to speech API, converted them all into reasonable sounding MP3s, and then it was able to post it all up onto my server in a really nice looking, easy to access, um, website that I think is that's supposedly screen reader compatible, which I have here, and it labeled everything what's going on, and I was able to do this in, again, a matter of over a course of a few hours while talking to other people and doing other things. And I think she's going to have a much easier time accessing this now. And if she does have issues with it, I'll be in a position where I can easily make changes to this. And before I just I just don't have the time to do it manually anymore. This is amazing.
Here, well, here's I did manage. Claude fixed the code while you were talking, and this is what the TUI looks, our text UI looks like. See, let me just get the Claude part of this out of here.
This
So,
looks great.
so this is Sigmon. Here's the overview. I'm using my mouse. Here's the configuration. You can do a backup. You can restore the configuration. You can look at the CPU affinity settings to see if they're correct, which they're not. Um, so this is alpha, not even alpha code at this point, but you can see, you can start and you can look at the status of all of you can see now most things run as system D services. So you can see here's a decoder service for this antenna on 12 meters. So each one of the decoders and there's a posting service associated with it. So you can there's logging, there's you can look at this status of different things, all done with the there's the example of what looks like Phil's control program that shows the list of all of the services being streams being output. So anyway, it gives you hopefully gives you guys some idea of this is, you still have to type git clone and cd.install.sh, but after that you should be able to go into here and everything should happen through this kind of a user interface.
This is amazing.
It's just yeah, here's the client services
Mm-hmm.
that where we could add more. This is where you can. I don't know that it's still selected. We have to kind of configure it to understand and make sure the client service there's a kind of API between the Sigmund and the client services.
Mm-hmm.
Um, the so the minimum amount of information exchange consistent with being able to install and manage and configure and monitor the operation of each of the clients. So
So I have so as you know, my students and I are working on this contesting dashboard.
yes,
Should that be show up as a client here, or how should we do that?
what is it? Where does it get its information from?
Well, I started asking about this a couple of weeks ago. What we'd like it to do is we'd like you to um, implement save the spots to a local database that's basically the
Oh
same
yeah. Oh
schema
yeah.
as your ClickHouse,
Yeah.
so that we can either point the system at the local device or point it at the main ClickHouse database.
That should be pretty straightforward. I just have to yeah, okay. Well, that might
Well,
take
on
an
the
hour.
backside, there's two faces to these clients. On the one hand, there's the side that faces Radio D and interacts with the radios, and then on the other side, there's the face that either uploads the data to an external database or stores it in a local database. Um, what is governing the relationship between Sigmund and each of these clients is a contract um, uh, with API and other kinds of basic structures. We've been iterating through what that client contract looks like so that it's hopefully as flexible as possible to allow different kinds of clients to develop, but also has a standardized structure so that as new clients want to appear and exist under the same aegis of control, um, it's easy enough just to integrate them. And so I think the part of the idea would be that a program like what you're talking about could run independently, but if you wanted it to run underneath the same architecture, simple adherence to the client contract would enable it to do so.
I got a question for you, Michael. I notice you're dynamically allocating SSRCs and channels. Do you need anything from me to cause a channel to time out when it's no longer being used, or are you handling that, or what do
I'm
you
not
think?
hand the way I handle it at present, and I think we actually briefly discussed this before. Um, my understanding of the way Radio D can dispose of channels that aren't needed is that you set them to frequency zero,
That's
and
right.
Radio D polls occasionally, and if it's one is set to zero, then it deletes it. So
Well,
if you
actually,
had
what you
it,
do is you set it to zero, then you stop polling the command channel. Otherwise, it'll keep running. Then you wait 20 seconds and it'll go away.
okay.
That's what happens now. I was just wondering if that's adequate or whether you would prefer something else.
Well, I suppose the way it's set up right now, what KA9Q Python does is set it to zero and then sort of just expects it to go away. Doesn't really
Yeah.
check anything else.
Yeah.
So if there
Well,
was a
I'm
more
also thinking about what
explicit
happens
sort of
when things crash, and having to rely on a program to clean up its own resources is always, in the real world kind of problematical.
at present, there's a fairly robust system of reestablishing the channels that the client needs. So I routinely test this with making Radio D go away or restart it. So
Good.
Radio D goes away. There are no defined channels in the Radio D config file, but the client is sitting there saying, "Where's my file?" or "Where's my stream?" And so it automatically rebuilds the stream. It sends the requests back to Radio D and they get immediately reconstituted within a minute. So
Right.
you get
Okay.
things
Well, that's
built
good.
back up again.
Yeah, I'm glad you're doing that because that makes it a lot easier for me. I don't have to try to save state through a
No,
restart of
I
Radio
wouldn't
D.
think so, but it would probably be cleaner if there was just an explicit command, kill this channel, boom, and then it would go away.
Yeah.
Um,
Well, I mean that it's pretty close to explicit now. You set the frequency to zero and just leave it alone and it'll go away.
and that
But
works.
if you
But
don't, it'll keep running forever, right? And it'll keep
correct,
producing data forever, even nobody's listening. Because I don't have any with multicasting on Linux, I don't have any easy way to tell if anybody's listening to me. It's kind of a
right.
shame, really. I can't even monitor the IGMP messages because to get around certain bugs in multicast aware switches, I have to join my own multicast group. So I always know there's going to be at least one listener.
Well,
you know,
can't we
need, right?
use IGMP query to can you
They
do it
get
two ways to
This was
check and see
this
if
was premature. This was premature optimization in the multicast specs, but they have switches coalesce those things. They were so concerned about whether this would scale up to billions of nodes on a multicast group that they put in all these optimizations that do things like suppress duplicate queries and so forth, and it makes it kind of harder for you to just watch what's going on by this kind of stuff. So I wouldn't rely on that. I mean, if I wanted to do this, I would need some kind of explicit heartbeat from the user, and then it would go away if I didn't get that after some period of time. But that would break existing compatibility. It would have to be an option because there are many applications now that just assume the streams are there and don't send any kind of a heartbeat.
well, okay. Although, the heartbeat has some potential advantages, and if it's something that we could set up on the Sigmund side or on any client side, it actually gets mediated through K9Q Python, that the library I wrote to mediate between any client on the back and Radio D on the front.
Mhm.
Um, uh, if I could set up a heartbeat in K9Q
Oh,
Python
the
that you
heartbeat
could
is
listen
very
to.
simple. Just pull the channel status. I mean, it's already there. I mean, the only change I would make is that if you didn't, it would go away even if the frequency wasn't zero. If you stop polling. I mean, that would be one way to do it. That'd be very simple. But then,
Well,
there
that's
would be
an interesting
backward,
idea.
you know,
Okay.
there'd be backward
And
compatibility. I mean, it would have to be an option because that would break backward compatibility with existing clients.
yeah. Well, let me give it
Anyway,
some
let
thought.
me know what you
That's
think.
not a bad idea. Uh, Make K9Q just do a little heartbeat for every
Well, to
channel that
require
it.
one, in other words. I mean, just require that, I could change the logic on this 20-second timeout thing very easily. So if it will facilitate what you're doing, just let me know.
Okay.
I may just do that. I may just, set some flags or something and just say here, use them if you want to use them.
All right.
Keep the same default behavior now,
Keep
but
the
then,
default behavior,
yeah,
but have a flag that if somebody wants to execute it, that's there.
right.
Hmm.
Change the
Uh,
timeout, change whether or not a poll is required to reset it.
yeah.
Because yeah, I mean, operationally now, I mean, we've been using this now long enough with enough applications that it would really be kind of nice to get rid of all the statically confined channels in KNIQ radio.
I agree.
That would be an easier
But at the
world.
same time, what I've experienced in practice as I've been developing this, doing the dynamic channel definitions, is that if you don't do it right on the client side, suddenly Radio D is producing you've never turned anything off. So um, having a default means where, look, this needs to be kept alive somehow, right?
Yeah.
Um, Keep it alive with a heartbeat. Otherwise Radio D understands it's going to go away. And if I know on the client side that there always has to be a heartbeat sent to Radio D to make sure this thing stays alive at a relatively reasonable rate interval, then Radio D knows how to pare down the streams it's producing, so it's just not
Yeah.
clogging
Yeah. I
everything
mean,
up
that
with unused streams.
heartbeat is very simple. Just send to the poll,
Yeah,
send us a poll.
that would be elegant, I think,
Okay.
and really help.
All right. I'll think about the minimal hooks to do this.
Great.
Would have helped us at KFS. It wasn't a big deal, but we did uncover there was one of the uh, systems that KFS was emitting a 300 megabytes per second of multicast. And
Yeah.
it just turned out that we had, I think you could,
Again, there's no easy way for me to find out if anybody's listening. Somebody had configured those for experiments with, well, those were the main offender there were those wideband channels that were being used as pre-muxes
yeah,
for the web SDRs.
yeah,
I
this
guess
is
she
this
turned
is
on
a,
and forgot to turn off, but
yeah,
I have no way of knowing whether anybody is listening or not.
yeah.
Although you could say that if somebody defines Radio D to produce a station or a receiver channel, you just produce it and boom, it goes. But for any dynamically created ones, maybe you require a heartbeat. And
I
so
could,
if the
yeah,
client goes away, the station goes away.
can do
So
that.
that way, you don't end up clogging the network with a bunch of totally unused packets flying back
Yeah.
and forth.
Well, that will be a per channel option. I'll make that a per channel option. I'll keep the current default so nothing will break, but you can set a flag that will say I require on this channel I require a poll at least every 20 seconds or wherever many seconds to keep the channel alive.
Cool.
So anybody else besides Clint in the FMT this last week? Like I said, I'm learning a lot about statistics and how little I know about it.
Lies, damned lies.
Yeah, exactly.
Statistics.
Exactly. I don't know if it's beginner's luck or what, but I guess it worked well enough that I put my code on GitHub. I'll put a link out here.
I will say, by the way, that all the code that we're working on is available on either Rob's or my GitHub site. So if anybody's interested in downloading it, in particular, that the probably the most critical potentiating code for the whole architecture we're building is the KA9Q Python library, which is the sort of generic interface to Radio D. So um, I've used that library for a variety of applications that have nothing to do with HamSCI. One is just downloading a shortwave listener database and listening to Radio D serve any of a variety of shortwave broadcasts that are published on the EIBI database. I'm doing something similar with 2-meter and 70 centimeter repeater um, lists from the AARL repeater book that's available online, National Weather Station broadcasts, that sort of thing. The KA9Q library, KA9Q Python library is also importable as a PyP, however you pronounce that, library install for any Python program. I uh, trying to build in a kind of automatic mechanism to make sure that when Phil updates his code, the K9Q Python code gets updated as well, so that it remains idempotent for downstream clients. But for the really critical stuff, Phil's code is nice and stable, so um,
Trying to keep
and
it that
one of
way.
the, it's so stable, and as a matter of fact, that I have all these interesting conversations with Claude Code about how, it's not Phil's code. It's not Phil's code. That's not the problem. It's my code that's the problem. So, fix it locally. Don't try to think that it's something wrong with what Phil's done. So,
The only rough edges right now, I think, are in this Spectrum code because that's the newest.
yeah, in fact, I don't know, I was thinking about putting a Spectrum client behind K9Q Python. It's So that is a sort of back burner project that I have in mind as well.
Okay. That'd be yet another way to use it besides KNIQ Web. That'd be great.
Yeah, and you wouldn't have to have it local on the Radio D machine. It wouldn't have to build against Radio D directly. You could just have a client optimized to be a Spectrum display. K9Q Python talks to K9Q radio, and
Yeah, I'd love to have people use your library or any library rather than like stealing my internal structures. It's got me in trouble a few times when I changed something that I thought was an internal structure and then it breaks something else somebody else was doing.
By the way, I've rewritten K9Q Python, so instead of having a web background, there is a fully interactive terminal user interface based on textual, which exposes everything that you already display using end curses on control.
Oh, cool.
So you can be sitting anywhere. You don't have to try to figure out how to compile control on your local machine in order to do this. You can run the TUI under with K9Q Python and just click on any SSRC in a particular multicast stream and see all the details, and the ones that are variable based on your own code on the radio decode, yeah, you can manipulate through the terminal user interface. So
Okay.
that makes life kind of easy, and it doesn't require a web server. It does require textual, but that's downloadable and importable pretty easily. It's a fairly widespread and widely used basis for a terminal user interface.
I'd like to
So.
see a demo of all this sometime because I haven't been closely looking at what you're doing. You're doing a lot.
Well, you're going to be at Hamvention, aren't you?
That's my plan.
Well, then we'll be there.
Yep.
Okay.
So
Yep.
it'll be, and I think, we'll be closer to beta then than we are, much closer than we are now. So
Okay.
and it's all, I think we're going to stick with, eventually maybe we could put in a web user interface, but this text mode is really easy to deal with, have Claude implement and change. And doesn't involve any dealing with browsers and URLs and everything. Yeah.
So Paul, what do you need for your QST article? And what part of I was suggesting that we meet
Yeah,
but
no, we definitely need to meet, but not the QST article. I've already put it in. I just
oh,
basically
okay.
um took the presentation I had given and sort of wrote 500 words about that, so, and in there I promise great things that will be done within the Whisper Daemon system in order to support this, broadly support all timing sources in the future and the ability to use them, but I don't provide any details. So I don't think I actually lied about anything technically. So we'll see. But
Well, you
but
got a future as a politician then, I
oh yeah,
guess.
no, I'm working on it. I'm seeing the job that everybody's doing, and hey, I can do that. Um, I can screw up just as well as the next guy. Um, but anyway, I would like to, probably in time for the Hamvention. I'm working on my presentation there now, and it'll be a Tapper thing. I'd love to be able to talk with some authority and some knowledge about how the time stamping or time synchronization stuff will be used and how those resources will be made available. Um, Presumably other people are going to develop um, demodulation, programs and time extraction, for, people are talking about, transmitting closest arrays of FSK and all sorts of things. And of course, my thing I want to do, which is the let's not call it spread spectrum thing. Um, and anyway, so I'd like to be able to at least have a clue as to how we're going to handle that within the Whisper Daemon network. And that was, I think one of the big selling points is that it will be all handled within the Whisper Daemon network, and provide sort of a uniform global approach to this, rather than everybody kind of ad hocing it one way or another. Um, so that's
Well,
what
what
I'd
did
like
you
to be able
think?
to talk about.
I What thoughts did you have regarding that taxonomy that I'd
I'm using
proposed?
I used it with the gave you credit for it. It's in my, hey, I'll show you my presentation before, long before it's ready to go out. But I like that approach. What I wanted to do with that is attach some actual time resolution or time accuracy numbers to each of those levels. Um, I can guess, but I'm sure you've given it some thought. Apply millisecond and microsecond numbers to those, um, just for, point of reference. Um, but yeah, I like that idea, kind of providing structure for, you know, what we can do and, what we can achieve in the various ways we can achieve a given level of performance.
Well, and then also report. The other feature I thought that would be beneficial or potentially useful for a taxonomy of that sort was in reporting what a given station was actually producing.
Yeah.
What sort of timing authority was involved in the recordings coming from station X, station Y, station Z. So, uh,
And we need to do something similar if we're going to have transmit stations other than WWV or well-known
right,
stations. Somebody may come up with something that, it's only accurate to within a millisecond, and which is great if you know that. As far as a transmit signal, if there's a time feature or whatever we want to call it, then how close is that, and how far removed, is it delayed by 57 microseconds from GPS second, or what is it? So I think that's part of the discussion I think we need to
yeah.
have. How do we handle transmit and receive and logging and access, and providing access to people who want to write their own decoders for measuring. Let's say they come up with a transmitter they want to use, because it's got some particular characteristics that they like. How can they use the Whisper Daemon or, Sigma network in order to, how can they tap into our massive worldwide global network of receivers, and know which ones have timing capabilities and to what degree? And again, that's the
Right.
discussion part. And I'm sure, we're not going to have it all figured out in time for the Hamvention, but at least I'd like to be a little bit more comfortable with it myself anyway.
Yeah.
Well, and then there's the whole part of it that deals with the underlying data models that are used on the analysis side. And what sort of, I have no idea how this fits with the happy model or with some other models that might be, that people might decide are going to govern the way we store the information and record the characteristics of the information that we have, for further use. So there are, yeah, there's a
Oh, I
on
hear
the
you now.
front end where we're trying to decide, okay, when did this signal actually arrive, and then on the back end, it's it's the same question, but just from a different perspective.
Yeah, and
Uh,
and I'm working from rather extreme level of ignorance here. So let's get together and talk about it.
Yeah.
See,
yeah,
and bring in the people who are actually going to be, people like
using the
Gwyn
data.
and others who are going to actually be using this, find out
Yeah,
what they want, what's going to
Hmm.
work for them, and what they don't need.
right.
Yeah. I think one of the things that we want is to save that track of the timing injector to the digital RF signal, to the digital RF system. And that will allow for post processing in a lot of different ways.
Well, again, I need a lot of education in this too. But
Yeah. Yeah.
And
what I'm
Nathaniel,
adding
And
right now is a JSON sidecar to the actual
okay.
IQ. The JSON sidecar containing some of the timing metadata about
Yeah.
what kind of timing authority is this been measured under? What is the offset? that we know about from UTC? Is the timing here governed by the HF injection? Is it governed by a GPS plus PPD part per second
Yes, yeah.
to the uh, to the machine? Is it a local area network time server with GPS plus PPS? Is it an NTP time server out on the WAN someplace? Is it the HF time standard reconstruction of UTC, which my software can do, which is better than NTP, but not as good as GPS plus PPS? Is it wall clock? What
Yeah.
is it? But the either way, we'll have the IQ and
Yeah.
we'll have the what is the taxonomy and what is the timing authority applied and what is the timestamp
Yeah.
with whatever
And
offsets that
th
we're
this is kind of similar, but not exactly, to like the stratum 1, 2, 3. Yeah,
Yeah.
that's used certainly in telecom, and I assume elsewhere.
So I
Nathaniel,
think yeah, I think some of this when you're starting to talk about the where it's getting saved and how all that works, I think talking with Bill Engelke and Christina Collins is going to be very important.
that's what I was going to ask you. I believe that Christina was going to be maybe kind of help coordinate,
Mm-hmm.
at least the transmission signals, the times, but other stuff related. And so I think we need to get in touch with Christina as
Yeah.
part of this discussion.
Right. Yeah. So Christina's always on the Thursday morning telecons at 10 a.m. And so I guess we need to invite her to come to this telecon, or some of us have to go to the Thursday morning 10 a.m. telecon. Both Christina and Bill will be at the Dayton Hamvention too. So you'll be able to talk to them in person.
that
Yeah,
that's
let's get
probably
this
a
start.
good occasion for us all to sit down and put our
Yeah.
heads
Yeah,
together.
yeah.
Yeah.
10 a.m. Does that mean what, like 7 a.m.
Yeah.
West
And
Coast time?
Yes.
yes, yes.
Oh, oh boy. Well, let's
See,
meet at Dayton then.
but I'm sure, and if you email her and Bill, they can arrange another custom time where we just talk about this. The other thing
Oh,
that's
yeah.
the other thing that's good to know and remember is that we have this GitHub board called the charrette that Christina organized, and that is the main roadmap that we are using for changes to the personal space weather station server. And I can put that link in the chat again here. It's projects PSWS design charrette. So like I'll put this in the chat to everyone in meeting. So this is like the project board that Christina has organized and she's working on with Bill Engelke. So I think it's whether you can see like there's a whole section there about happy interface into the PSWS database. So you're free to peruse this and see how it's thinking. But I guess it's also important to kind of know that this is around so that as we're trying to make changes to the PSWS system, make sure you let Christina and Bill know and then have it tracked in this system.
I think one of the things I found, um, I have no knowledge of Happy at all.
Right.
I don't know what it is. I don't know what it was created
So,
for. I don't know what
okay.
it's supposed to
So
solve.
I
But
I can tell you that. I can tell you that. HAPPY stands for the Heliophysics Application Program Interface.
well,
And
that
the
clears it up.
idea so the idea is that if you're a heliophysics person, which I am, so if you're doing ionospheric science or magnetospheric science or any sort of science that's impacted, the sun and the geospace system, that's heliophysics science. If you're in that group, you're considered in heliophysics. So that's where we fall. There are a number of different databases out there. So we have our personal space weather station database. There's another database called the Cedar Madrigal database that the MIT Haystack group runs, and that there's a bunch of data from other heliophysics scientists that goes into there. There are data from different NASA missions that go into something called CDA Web, Coordinated Data Analysis Web. There's I think there's also something called SuperMag, which Jesper Yarlov at Johns Hopkins Applied Physics Lab. He coordinates downloading magnetometer data from professional magnetometers all over the world. All of these different databases are in different places, and there are different ways that you access the data. So the idea behind Happy is it's supposed to be one API that all of us databases agree on using so that you can access the data from these different databases using through the same API. And so the idea, if we're able to make our personal space weather station database Happy compatible, Happy compliant, then that's going to make our data more accessible to scientists and presumably other people who learn how to use Happy as well. So it's basically a standard.
So is the standard for data exchange, or is it standard for actual data elements? I mean, so just for instance, the taxonomy that I just outlined of timing authority for recording what kind of governance there is of the IQ stream.
Yeah, so this is where I think talking to Bill Engelke would be really useful, because Bill has been spending many happy hours talking to the happy people. And so he has been spending a lot of time thinking about how what we're doing with the personal space weather station project maps to the Happy API and vice versa. I think there should be an extension to Happy. So the Happy heliophysics heliophysics application programming interface, and then it should be solar astrophysical data. So it'd be Happy SAD.
Just to capture the schizophrenic
that's right.
character of the science. Excellent.
But that's the whole point of Happy. So I think right now, I think you're still with the whole timing thing and all of that. I think you're still kind of at a lower level part of this. I think to start getting up to the higher level, in understanding how it's going to be used and stored downstream, I think talking to Bill Engelke is important. I think other important people to talk to will be the people at MIT Haystack, because Phil Erickson, he was the one that recommended to me that we do this whole time injection thing. I think it's been recommended here as well, but by other people on this call have also recommended it. But I think MIT has a case where they are doing this and they are actively using this sort of approach. So we might be able to talk with their programmers and get some feedback.
There's two ideas here, though. One of them, of course, is what's the best timing authority? And I think HF injection is premier, right?
Right.
But the other is, this is citizen science, and not everybody has an HF time injector. How do we categorize and how do we enable the usefulness of data which is captured under some timing authorities which are not quite so rigorous as HF injection?
Well, one of the things with the digital RF format is you can have metadata streams.
Yes.
So you with every timestamp, you could have a quality flag. And so with that quality flag, it could be like, a number 1 if it's HF time injection, a number 2 if it's something else. And, it could kind of fall down the list. And if there's no information, you could say it's kind of the least trustworthy. But I guess, again, you have to come up with a standard of how you do that and how you save all that information.
Right. That's precisely.
Which is why I mentioned the stratum characterizations, although those are more one's derived from the other and then derived from that and then derived from that, rather than independently
Yeah.
But still a definition and a name for a particular level of accuracy.
Yeah.
We just need to agree on something unless there's already some standard out there we can use.
Right.
Which
That's
is,
what I was.
and that's one of the reasons I recommend and I can make this connection too. We reach out to like MIT Haystack, see what they're doing.
Yeah.
Because I can make up stuff. I mean,
Yeah.
I can make up stuff.
We,
Watch me pull a
well,
rabbit out of my hat. But
well,
it would be
I mean,
nice to.
yeah, but and again, actually, Claude is, as you know, Claude is very good at this. I mean, I was thinking about this the other day. Like Claude is, all the time when when I'm working at the university, I'll say I want to do something. It'll say, well, what is everyone else doing? What is like large language models kind of by definition are take what everyone else is doing and put it into some statistical model that tells you the most probable thing.
Whether or not
So,
it's the right thing to do.
Whether or
right,
not.
right. But that wasn't the question. The question was, what is everybody else doing? so like, I mean, it could give you some, it could give
Yeah,
you
but
some
I
good
mean, remember
guidance.
your mom asking you if somebody jumped off the bridge, would you follow them?
Oh,
Then it's up to you to decide. But I mean,
But did
but
everybody jump off the bridge, or only one
yeah.
out of 50? So,
And so anyway, one connection I can offer is I can offer that connection to the MIT Haystack Observatory, and they have a number of people that are doing this sort of thing, and we can talk to them and see if they have some guidance for us.
as long as we're talking the same language, I think that's
Right.
cool.
Yeah.
Is Phil Erickson going to be at
Yes.
convention?
I don't think he will be,
Okay.
but I think we could arrange a telecon or an email exchange or something like that.
Okay. The other person is Heisel.
Yes.
I haven't followed up with him on the conversation we had at AGM. AGU. I have a battery underneath me.
Yeah.
So I was thinking it would be timely now to follow up with him. I don't know if
Yeah.
he seems to be fairly ham active. So
Yeah.
I
think I'm sure he would have great ideas on this.
Yeah, well,
And
one of
would
our
be
goals,
very,
what kind of his seeing if we couldn't collaborate with him on his using his transmitter and
right.
our network of receivers to look at his gather data for him.
Right.
Seems like would be really interesting to me.
Yeah.
Uh,
I think that's a very good goal.
okay.
Now before I go, because it's like 10:20 p.m. here, and so I'm for the QST article, for the name of this system, I sent an email out earlier today saying what do I call this? Like, what's the headline going to be? I've been calling it the Whisper Demon Grape. I can do that. I could call it the HamSCI MFHF instrument. I could call it the HamSCI TAPR MFHF instrument. Does anyone have any strong feelings? In the article, I will try to acknowledge all the people that I'm supposed to acknowledge.
I'm your choice. Whichever communicates best to readers what this system does. You don't even Whisper Demon is a mouthful, and,
Yeah.
So I've been, I've it was
I kind of like the HamSCI HF receiver.
That'd be fine.
Or HF instrument.
Okay.
Well, there's the instrument, which is,
hang on a second.
I guess, a personal space weather station, right?
Right.
Receiver and computer and, what antenna and all that. And then we've got the system that all of these individual stations are sending data to.
Right.
And then people are accessing that, which is Whisper Demon, as far as I know. People are accessing that to pull data out for analysis. So I don't know. I guess the question is, what are we talking about? And then what?
I think in this article, the goal of this article is to get people to want to set up one of these RX888 receivers in their house. So it's like the HamSCI HF receiver.
But they're
And
going to want to know what it connects to as
and
far as the
well,
uplink.
so I mean, I'll explain all of that in the article.
Okay.
So,
Why
but I'm
does
just like,
personal space weather station not do the duty?
because the personal space weather station would nominally be, this would be one part of the personal space weather station, because the personal space weather station includes the Whistler catcher, which is the VLF part, and the ground magnetometer and the HF instrument. So this is one part of, that's why.
Oh, so I guess I didn't appreciate that. So which part of it are you talking about then? The
The
HF part only, or
Yeah, the
okay?
RX888 part that
Well, the
we're
RX
working in.
AAA part is not just Whisper Demon though. It's Whisper Demon, it's WWV, it's
I
PSK, it's
yes, I that's exactly, which is why I'm
and
trying to
and that's why
figure
we,
it.
when we came up with the moniker Sigmund, it was really Signal Monitor Demon
Yeah,
for HamSCI. But
Sigmundy.
um, again, not that that's the best term, but the idea is to get away from the idea that just one of those signals, like
Hmm.
Whisper, was predominant. It's not, Whisper is really important, but it's
Yeah,
not the only signal. So
yeah.
monitoring all these HF signals. So your idea of an HF monitor or something like that is getting at it if you're talking about receiving things with the
If I call it
with
the
the
HamSCI HF receiver, that covers kind of all the bases.
it does. Yep.
Yeah,
Because it's HF and it's under the aegis of HamSCI and it includes any signals we could come up with.
and that'll be a really easy article title, and then I can explain everything else in there.
Yeah, I mean the only reason not it, and yes, and you're describing the personal station space, and that sounds like you're doing it well here. That's a good name for it. Uh, but again, the Whisper Demon network, yeah, I mean the only reason I'm calling it Whisper Demon now is because I'm used to it and everybody else is used to it. I think Sigmund is as good as anything for the new name because, hey, we're not just, it's like it's instead of psychoanalysis, it's spectral analysis, right? Uh,
Yeah,
but it's all, but if I were to, in the one of my presentations, if I were going to talk about Sigmund, even if I explained it, at right now, 75% of the people wouldn't know what I was talking about.
I think
So
if
we need to introduce that name. If that's the
yeah,
name, we need to introduce it. But
and that's still like the software part of.
Correct. It's just the
software and
software.
servers,
I
yeah.
I think if I call it the HamSCI HF personal space weather station receiver, HF receiver, I think people will recognize that.
Ham
Yeah.
size already out there. HF is clear.
Yeah.
Um, we're we're not just receiving because Paul's got transmitters.
But
So
but that's different. Then we would call that that would be an article about the whisper sound.
for now,
And
but he can broadcast more than just whisper.
as can
Right.
lots of other people. I mean, yeah.
Right.
Yeah.
So,
But that's a different system than
that
the
is
one
a
we're talking about here.
right.
Yeah.
Now you're talking about the receive end,
Yeah.
and people with these receivers, they then send it up to,
Yeah.
the big network in the sky here, which used to be called Whisper Demon,
And
and it's
and like
probably called
I
something
could
else.
have a paragraph that kind of gives a sentence about these are the other components of the personal space weather station. There is a ground magnetometer system. There's a VLF Whistler catcher receiver. There is a whisper sound transmitter. These are all separate components that are part of the personal space weather station suite of instruments and network. But
And
in this
they
particular article,
and
and
they may
they're
be
all
sending their data to different
yes,
servers too. So it isn't
yes,
just
right,
the the system formerly known as WhisperSound. Um,
right,
It's
we
a
need
it's a big tent. Big
mm,
tent.
yeah.
right. Okay. Well, I think that gives me enough guidance to kind of like get a draft. I will have to write a draft together write a draft this weekend. Like I have to because it's due Friday. So I guess by Monday I will have a draft that I will circulate among people, and I'll be on this call next week. I'll be like, "Hey, did you read this?" And then we'll get that out there.
Would you like me to circulate mine? The thing I submitted. I mean, the ARRL guy seemed to be happy with it, but
Yeah,
if
if the AWORld's happy, I'm happy.
okay, I mean, I don't mind
Yeah,
sending it out. I mean,
yeah. So
and
no,
there is time to
yeah,
make changes, but
you're
what mine is generic enough. I don't think it's really a.
yeah, you're more than, I mean, by all means, feel free to circulate it. I'll be happy to look at it. I think that this, so what they did in the issue last year was they had one or two kind of lead long articles that are 1200 to 1800 words, and then they had that was followed by a bunch of these 500-word articles. And so the one that I'm writing, I think, is going to be kind of more of this lead article that's like, hey, here's what a personal space weather station, what this HF receive instrument is. Here's how you go about setting it up, and we have to put all of that together.
I'll send you my text, Nathaniel,
Okay,
just so you can,
so I
take a look
can,
at it, see
that sounds, yeah, that sounds great.
And
Yeah,
Nathaniel, one thing that I was thinking of that since we're trying to come up for a name with this thing,
mm-hmm.
So what I came up with was a name for the whole system, and not just like not just say the hardware or the software, and I think people were kind of confused as to what we're trying to come up with, but it's the name for the whole system, the whole thing, including both hardware and software. Um, so, and that was the idea of the name that I came up with.
Right.
So just so people understand it's the whole system and not necessarily one single software or hardware component. But anyway, before everyone leaves, I just want to share quick the logo that was designed by Creative Services at the University of Scranton. They're where did the window go? So yeah, here we go. So come on. Okay. So the idea with this logo was to have a logo that can kind of embody the mysticism of the system and natural radio missions, but also something that people remember, something that looks cool as a marketing thing. And whoops, where's the? Here it is. So that's the logo. So the shape of the Whistler curve that was actually based on the shape of the very first Whistler received on my prototype system at Nathaniel's. There's two versions of it here, and I think it looks amazing. It looks extremely cool. And it absolutely embodies what I had envisioned for this system. So I'm actually quite pleased with it. I want to put it on everything. I want to print out stickers and put it on clothing and
I hope
everything.
Amazon doesn't mind.
Why?
Well, it kind of makes me, what do you think? I mean, kind of vaguely resembles the Amazon logo.
Oh, it's at an angle. Come
I
on.
know it's at an angle. It doesn't have the little edges on it,
Yeah.
Yeah, I agree. And Jonathan can trace his back to actual like scientific data. So I mean,
Yeah, okay.
So this, yeah,
It
this
doesn't evoke that to me.
I provided a actual Whistler spectrogram from the system, and Creative Services used their image editing software to uh, create this curve, and it looks exactly like the Eckersley curve, or the Eckersley dispersion law, that makes whistlers sound the way that they do. And that was important because when you're uh, designing a logo for something like this in engineering and science, you want to be accurate with what you're describing. And so I made sure that they were accurate to the Whistler curve. So this actually looks quite awesome. Looks like a Whistler, and it was based on an actual real Whistler, and the first Whistler that the prototype system received. So, um, so you'll probably be seeing more of this, and on ver- ver- various different things, and hopefully by how cool this looks, people will get interested and excited and want to put up one of these systems. Um, so that's all I have for that. And I'm working on asset labels with this logo. So, any comments other than Amazon?
Looks good.
I really one thing I really like about it, Jonathan, is how you actually got the got that curve from the data. So
Yes,
I think it's nice to be able to explain that to people.
yes, and that was important because I just didn't want any Whistler, or any generic shape. I wanted it from an actual Whistler spectrogram. So I was I mean, I don't know how Vicky did it, but she got it perfect. And I was even going through the other versions of the logo that she had, where she kind of directly pulled out the Whistler from the spectrogram image, and the curve just fits perfectly. I don't know how she did it, but it fits perfectly. So that's why that I'm so excited about this logo, is since it is from actual data.
That's really awesome.
That's all I have.
I think that's all I have for tonight also. Oh, I can say one other thing. I had Claude while we were working, I had Claude develop a quiz app for the Blind Association as well. So this matches all of the organization that Handy Hams uses for their lectures. And so hopefully that's available. That'll work on the iPhones with the screen reading now.
Good work.
Yes. Claude was awesome.
Night all.
Good night, everybody.
73.
73.